All right, so way back in December, before we went on winter break, we started off this unit by looking at variables, which we defined as named containers that could hold values. Today, we're going to be building upon that knowledge of variables to now add this new concept called conditionals. And conditionals in programming help us to answer questions and make decisions. So before we actually talk about how we make decisions in code, I want you to think about how you make a decision in everyday life. So if you would go to your Pear Deck tab on your computer, I want you to take a moment to think about and then write an answer to this prompt. So I want you to imagine that you want to make a decision about what to wear to a particular event. I want you to think about and then name two pieces of information you'd want to know to make this decision. And then how would you use this information to actually make the decision? So take a moment, think about what at least two pieces of information you'd want, and then how you would actually use this information to make your decision about what to wear to an event. I'll give you a moment to do that. All right, so there's no right or wrong answer here. I just kind of wanted y'all to brainstorm what kind of information would be relevant for you to make a decision like this. So let's go ahead and take a look at the stuff y'all came up with. So some common answers were like, is there a dress code? Is there like specific stuff that the party throwers want us to wear and to not wear? Another thing was, the location. More specifically, some people said, is it inside or outside? Because they want to know if they should dress, like in short sleeves and shorts, if it's outside and warm, or is it inside? Maybe it's more formal. Will it take place in morning and night or night? So I know in the last period, people were also wondering about the weather, right? In some places in the wintertime it snows, and so that's going to um, impact the stuff that you might find appropriate to wear to an event. The other thing was, what kind of event is it? Is it casual? Is it formal? So that's really going to depend. That's really going to impact your decision in what you're going to wear. Oh yeah, someone else said weather here. Again, restrictions. So is there a dress code? So you'll kind of like have a good idea, consistent idea of like what are some relevant details you would want to know in order to make this decision. And so that's going to come in really handy when we start thinking about how we can build systems that make decisions for us based on code. So we're actually going to come back to this, probably not today, but when we finish this lesson up on Thursday, we'll come back to this and think about how we would actually implement this in code as well. But to get there, let's introduce a few new concepts. So if you were with me last semester, we introduced a mental model of variables. And a mental model is basically something that's tangible and not abstract. So we used plastic baggies in our case, since we're in distance learning, we used virtual plastic baggies to represent named variables that contain values. And our values are represented by these sticky notes that you see here. If you remember last term, we talked about two different types of values, and we used yellow sticky notes to represent number or numeric values. We used red, or this kind of like pink color, to represent string values. Now, strings are basically like anything you can type on a keyboard. So words can also be numbers, but the difference between a string and a number is that it's surrounded in quotation marks. So you can see here, this value here, 1, 2, 3 in between quotes, is a string. This over here on the left, just 1, 2, 3, that is a number. Okay, so this, everything on the right here is a string made up of characters. Everything on the left here is numbers. Now, we've talked about numbers and strings last semester, but today we're also going to introduce a different data type called Boolean. And a Boolean can be one of two values, true or false. So they're meant to represent like yes or no, true or false. We will be using blue sticky notes to represent Boolean values as we build upon our mental model of variables and now conditionals. Okay, let me know if you have any questions as we move on. So this is a basic example of what a Boolean expression is. A Boolean expression can be evaluated to true or false. This is going to look kind of familiar to you. You know, you evaluate these types of expressions in math class all the time. Is 3 less than 8? So anytime you see one of these comparison operators, it means you need to stop and you need to compare these two and determine whether or not the statement is true or false. So you'd ask yourself, is 3 less than 8? Why, yes, 3 is smaller than 8. So this Boolean expression is going to evaluate to true. Now let's pause for a moment and talk about the different comparison operators that we can use in JavaScript, which is the language that we use in this class. So there's 6 of them that we're going to introduce. The first 2 look very familiar. You use them in math class. We've got the less than and the greater than. Same exact thing that you see in the math textbooks and what you write. The less than or equal to and the greater than or equal to are slightly different. You're probably used to seeing something like this and something like this. but it's kind of hard to find that symbol on a computer because we don't actually have those symbols on the keyboard. So instead, what we do is we type the less than symbol followed by the equal symbol for less than or equal to, and we type the greater than followed by the equal symbol for greater than or equal to. The next two things are probably not something you've encountered in math class. So when testing for equality, instead of using a single equal symbol, we use what's called the double equal symbol. So you have two equal symbols. And that's testing to see if two values are the same. The last one, you'll notice that there's an exclamation mark here and then equal symbol. In most programming languages, the exclamation mark means not. Okay, so we'll actually see this more examples of this not symbol later on. But right now, I just want you to recognize that the exclamation mark followed by an equal symbol means not equal to. So these are great symbols to become accustomed to. Once again, these are called comparison operators, and they are used in Boolean statements, which is just another word for conditionals. Okay, so don't worry if you didn't get all of this because I will be uploading the video of class after class today. So you can always go back and review these things. All right. So let's look at an example of a statement that not only has comparison operators like less than, but there's also mathematical operators. So mathematical operators are like addition here, subtraction, multiplication, division. So anytime you have a side of a Boolean expression that has a mathematical operator, you need to reduce that statement to a single value. Okay, so what that means is I see 3 plus 6, I can reduce that now to just the single value 9. So now instead of 3 plus 6 is less than 8, I have this simplified statement of 9 is less than 8. And now I can evaluate this reduced conditional statement and ask myself, is 9 less than 8? No, 9 is bigger than 8, so I know that that's going to evaluate to false. That's a false statement. 9 is bigger than 8, not smaller. Okay, so now with this information, let's get a little bit of practice. So at this point, I'm going to have you practice. Now, let me show you how I want you to kind of annotate this. This is what I want you to do. So I'm going to do the first one just as an example. Some of you are already starting. Great, I see someone doing exactly what I want you to do. So what I want you to do is kind of draw the line showing that you're going to reduce these mathematical statements. So 6 minus 3 is going to get reduced to 3. 4 plus 5 is going to get reduced to 5. So now what you're actually evaluating is 3 less than 5? That's true, so you're going to go ahead and write true. Now you can do the remaining 3 problems in the same way. So make sure you annotate the actual expression to reduce the values on each side of the comparison operator, and then write the appropriate Boolean value that it resolves to. Okay, so I'll give you a moment to do that. If you have any questions, feel free to ask in the chat. But at this moment, you need to switch over to your Pear Deck tab and annotate the screen. good question, Gwyneth. So the double equal sign just means it's checking to see if the two sides are the same, that they're equal. And I'll talk about, a little bit later, I'll talk about what the difference between the double equals and the single equal sign is when we're programming. But right now, just know that the double equal sign means you're checking for equality. You're literally asking, is this equal to this? All right, I'll give you another little bit. I see a few people still working. So remember to also write whether it's true or false on the blue sticky notes. All right, so it looks like most of y'all have gotten in your answers. So let's go ahead and check. I'm going to go ahead and just annotate my screen. And let's see here. So this first one, on the left-hand side of our operator, we have 12 divided by 6, so that's going to reduce to 2. And then on the right-hand side of our operator, I'll go ahead and circle the operator, we have 3 minus 0, so that reduces to 3. So now our entire statement reads as, is 2 greater than 3? So 2 is not greater than 3, so we know that this is going to be false. And then down here, we got to be a little bit careful, right? We see that we have parentheses here. So we have to remember our PEMDAS rules. We have to do what's in the parentheses before we actually do this multiplication. So we're gonna reduce this statement first. So 7 minus 3 is 4. And now we can go ahead and multiply that by the 3. So that'll get reduced to 12. And I'm going to go ahead and circle the operator. So now we have 12 is less than or equal to 10. 12 is not less than or equal to 10, so that's going to be false. And then finally, we've got 9 plus 5. So let's reduce that to 14. We've got the double equal symbol, which is asking, is this side the same as this side? So 4 plus 10 is also 14. 14 is indeed the same thing as 14, so this is going to be true. Awesome. So it looks like all of you pretty much got that. Awesome job. Let me know at any moment if there's any questions. Please do feel free to interrupt me on the mic as well, but you could also type in the chat if you have questions or comments. Just a reminder for y'all. Okay, so I'm going to go ahead and I'm going to clear the drawings. And let us move on to the next slide. So now we're going to use that mental model that we started learning about last semester. So remember again, we have been using plastic baggies to represent variables. And to kind of remind you all, variables have names. So you can see that this one right here is named lives. And variables also contain values. So in this case, it's containing the number 5. Okay, so we've got a variable called lives that contains the number 5. On the right here, we have another variable called score that contains the value 10. Now, that's all stuff that we kind of knew before from last semester. But what's new is how we can use these variables in a Boolean statement, a Boolean expression. If you remember from last semester, anytime we see a named variable in a piece of code, that means we need to look inside of that variable, look inside of that container, and see what value it holds. Then at that point, we can replace that variable with the actual value. So in this case, we see this statement that says lives plus 4 is less than score minus 1. So what we got to do first is we got to say, okay, well, what is lives right now? What does lives have? Lives at this point has the number 5. So what we're going to do is we're going to bring that value down and put that in the statement. So instead of lives plus 4, what we're really saying is 5 plus 4. And then the same thing for score. We see score minus 1. And if we look inside of the score variable, we see that it contains the number 10. So we're going to bring that down. So now instead of score minus 1, what we really have is 10 minus 1. And now we can reduce. So we know that 5 plus 4 is 9. And we know that 10 minus 1 is also 9. So we're going to reduce both sides. So now what we actually have is 9 is less than 9. And if we think about the truth of that statement, it's false, right? 9 is not less than 9, it's the same. Yeah, it's equal to. So this statement is going to evaluate to a false Boolean value. Okay, so just a note, any expression that can be evaluated as true or false is known as a Boolean expression. So this right here was a Boolean expression. Cool. Now, I want you to think about this. Here is another question. Can I go to the movies? Now, in this case, I'm telling you what information you need to know. I'm telling you that you're allowed to go if the time is before 8 o'clock. So what would make sense for a variable name to hold this information? So again, the question I want to answer is, can I go to the movies? And the information I need to know is if it's before 8 o'clock. So what would be a really good variable name to hold that information? What would be a good variable name? So at this point, you can just write it on the plastic baggie. I don't want you to write anything on the sticky note because that's going to be the actual value. And I just want to know a good name for the variable itself. So take a moment, think about it. Already seeing some good answers. Oh, someone erased their good answer. Right, so I'm going to show a few. This person was uncertain of their answer, but yes, time is a great name for this variable. You see time here. I also saw current time, which is also another great variable name. So I just kind of want to remind you of what makes a really good variable name. So let me add to this screen here. So go back to my screen now, if you're not already there. So good variable names. So this is something we covered last semester, but we can always it's always useful to remind ourselves. So variable names should be meaningful. So I know, like, if you read computer science textbooks or look at examples online even, a lot of times, it'll be like a math book where it's like the variable's name is X or Y or whatever. And that's not meaningful, and it's not helpful when you're writing real code that is used in an application. So in this case, since the information we need to know is the time to see if it's before 8 o'clock, it makes sense to name it the variable time. Another good convention of variable names is have it be short, a short name, right? So like time is just 4 characters long. That's a great name because if you're writing code, potentially you're going to have to be referencing that variable name over and over in your code, and you don't want to be typing a bunch of characters each time. So short and meaningful. And then there's just some nitpicky things like that will actually break your code. You can't have spaces. So for instance, someone had put in current time, so you can't have something like current time with a space in it. That's why we saw that person answer as current time like that, right? They put it together. Which by the way, that's called camel casing. That's another a good rule to adhere by, is to use camel casing. So camel casing is basically if you have 2 or more words in your variable name, the first word is going to be lowercase, and then any word that comes after it, the first letter of that word is going to be capitalized, and it looks kind of like a camel's hump, which is why it's called camel casing. So as an example, I'll put what was it, current time, right? So that's an example of camel casing. The last one that I'll talk about is your names can't start with a number. You can have a number in your variable name, it just can't start with a number. Okay, so those are things that you just kind of want to be aware of while you are learning good programming habits. All right. If there are other ones that come up, I will remind you, but those are all the main ones that I can think of right now. Yeah. So any questions at this moment? I think that's where we paused last period. Let's see what we got going on. Yeah, that's where we paused last period. So that's where we're going to pause as well. We will try to finish this up next time. If not, we will finish it up in the following week. There is no homework or anything like that. I would recommend, looking over the video again once I post it, just to make sure that you got all the concepts. And I will be posting this video probably after lunch today. All right. So I'll stick around in case there are any questions, but you all are free to go, and I will see you on Thursday. Just a quick reminder, Friday is a 135 day since we did not have school on Monday. Okay, so Friday is a 135 day. All right, everybody, have a good day.